All right, welcome to 1.3 day 2. Let's go ahead and start with our bell ringer. So yesterday we talked about how we can find the limits of an expression or an equation by just simply plugging in that value that we're looking for, as long as that value does not make my equation or expression not possible. So I have something squared, I have no fractions, so I have no denominators to worry about. So when I have polynomials, I can just plug that value in. So I can take 6 times 3 squared minus 10. 3 squared is 9, so 6 times 9 gives me 54 minus 10. So that limit is 44. Likewise, I have another polynomial. There's nothing that'll go into this polynomial that'll make this not possible or not true. So we can go ahead and plug in 1 for my x value. Man, sorry guys, my touchscreen doesn't want to do it today. Alright, so 1 squared is 1, 3 times 1 is 3, plus 5, minus 10. 3 plus 5 gives me 8, minus 10 more gives me negative 2. So the limit of x as x approaches 1, of 3x squared plus 5x minus 10 is negative 2. Alright, trig functions. Whoop whoop. So let's first talk about sine. So the limit as x approaches c of sine of x is just sine of c. So again, just like yesterday, I took a look at the function. If it makes it not possible, then I can't plug it in. But if it is possible, I just go ahead and plug it in. Same thing with cosine. The limit as x approaches c of cosine of x will be cosine of c. Same with limit as x approaches c of tangent of x. I can just go ahead and plug in tangent of c. But you guys can figure out this next one. The limit of as x approaches c of cotangent of x is just cotangent of c. How about the limit as x approaches c of secant of x? Well, same thing, just secant of c. And my last one, limit as x approaches c of cosecant of x is just cosecant c. So we can find the limit of numbers, we can find the limit of expressions, we can find the limit of scalar multiples, and now we can do trig functions. So let's go ahead and take a look at that first example. The limit as x approaches 0 of tangent of x means that I can just plug in 0 for x, which if we don't know that off the top of the head, or we don't have our handy dandy calculator, we can find the sine of 0, because we all know that chart, don't we? Because tangent is sine over cosine. So I can find sine of 0 over cosine of 0. Sine of 0 is 0. Sine of cosine is 1. 0 divided by anything gives me 0. Alright, let's take a look at this next one. So I have the limit as x approaches pi of pi cosine pi is essentially what this problem is asking me. So pi times cosine of pi. Pi is 180 degrees, or again, I can plug it in my calculator. So I want the cosine of 180 degrees, which is equal to negative 1. So I have negative 1 times pi which gives me negative pi. Now, we're going to leave it in terms of pi unless it tells me specifically to change it. It doesn't tell me here, so we're just going to leave it as pi. Next one, I have the limit of sine squared of x when x approaches 0. So even with my squared terms. So what we do first, sine squared of 0 is the same thing as sine of 0 quantity squared. Well, we already said sine of 0 earlier was 0. So then I have 0 squared, which is still a big old 0. Okay, dividing out and rationalizing limits. So we said we could plug in that value as long as it doesn't make the expression or the function not possible. Well, sometimes we're asked to find it for when that value makes it not possible. So what I'm going to look for first is to see if I can factor. So if we take a look at this example on the left, I have x squared plus x minus 6. I know I can factor that top out, so let's try and factor it. The only thing that can multiply to x squared is x times x. Well, multiplies to negative 6, adds to 1. Well, plus 3 minus 2. Woohoo! We have a term canceling out. So then I'm left with x minus 2. Well, I still don't have a limit. Now what I can do is plug in this x value, because if you notice, this expression will never be not true, because I don't have anything that would make it undefined. So then I can plug in that negative 3 for x minus 2, and therefore my limit is negative 5. So when I see fractions, or I see an expression involving multiple terms on top and bottom, I'm going to look to see if I can factor first. So first step always is going to be factoring. Alright, let's go ahead and look at the second problem. Only thing that multiplies to x squared is x times x. Then I ask myself what multiplies into negative 20, adds to 1. We get positive 5 minus 4. I have my x plus 5 on the bottom. Those terms cancel out. I'm left with x minus 4. Now I can plug in that negative 5 in there. My limit is negative 9. So now that we have seen how to solve fractions if they make it not possible, remember we just factor. Okay. Well, if you take a look at these next two examples, my first thought is, well, maybe I can factor just like the last ones. But I don't have x squared terms in here. So what I'm going to do with these I'm going to call what's called rationalizing the numerator. So we're going to write a note at the top. Oops, my M just does not want to stay together today. So we've rationalized the denominator by 4 when we dealt with our conjugates. We saw conjugates a couple weeks ago when we were practicing to prepare for calculus. So same idea, only now we're going to do it to the top. So to rationalize the numerator, I'm going to multiply by the top with the opposite sign. Okay, so I'm going to FOIL. So I have this chunk times this chunk, which means I have the square root of x plus 1 quantity squared. Because I have that times that. There's two of them. And then I have 1 times the square root of x plus 1, which is the same thing as square root of x plus 1. Then I have 1 times the square root of x minus 1, which means I have the subtraction of that. And then I have negative 1 times 1. Now, on the bottom here, I'm just going to kind of put these together. I'm not actually going to multiply it out. The whole reason is we're trying to do some canceling. We want factors to pop out. And remember, we can't cancel things when they're just being added or subtracted. We need some multiplication going on. So I'm not going to actually multiply out the bottom. So just leave the bottom alone. Okay, so I have this on top here. I have the squared times the square root. Well, we should know that those are the inverse operations of each other. So I'm left with x plus 1. Next, I have the square root of x plus 1 minus the square root of x plus 1. Well, lo and behold, those are going to end up canceling on me, which is what I want. And then I have my minus 1 following with. My bottom we haven't dealt with yet, so we're going to leave it the same. Well, on top I end up having 1 minus 1. Those end up canceling. Then I'm left with x over x times the square root of x plus 1 plus 1. If you notice, x by itself, remember, these are gone. And x on the bottom, that x is being multiplied, so I can cancel those out. So I'm left with 1 over the square root of x plus 1 plus 1. Well, I've rationalized my numerator. I've got other stuff on that bottom. So I was looking for the limit as x approached 0. Now that I don't have anything that's going to make that not possible, I can plug in that 0. So I get 0 plus 1, which is 1. The square root of 1 is 1. So then on the bottom I get 1 plus 1, which is 2. So that big old limit there ends up being 1/2. I know, a lot of work for such a little answer. I'm going to move some of this over so I have room because I write such quite large. Okay, so no green, red, or purple, so we're going to do this one in blue. So we're going to approach this next problem exactly the same way. We want to rationalize that numerator. So we're going to multiply by the opposite of what I see on top. So I'm going to multiply by x plus 6 plus 4. Okay, well, let's think smarter, not harder. We know on my original first problem that we looked at, here we go, where's my mouse, that my square root parts ended up canceling out, and I just got what was underneath. Okay, well, I know I'm going to multiply these out again. I'm going to get the square root of x plus 6 times square root of x plus 6, which means those square root parts cancel out. So I'm going to get left with x plus 6 on top. We know that if we multiply square root of x plus 6 times 4, it's going to give me 4 square root of x plus 6. And then if I do it again with the negative, they're going to cancel each other out. That's the whole point. We want to get rid of those. So we don't need to write those. So when I'm doing these problems, the only multiplication I needed to do on the top anyways, first times first and last times last, because of the fact that we're getting rid of those middle parts. So because we cancel out the middle, we know they're going to cancel out. We're making it happen that way. We don't need to write them because they're just going to take up more space and confuse us. Then on the bottom, I'm going to leave my x minus 10 times the square root of x plus 6 plus 4. So I'm just sticking them together, because remember, the idea is to cancel stuff out. We can't cancel it out unless it's being multiplied. Alrighty, let's take a look at trying to find a different color. Let's try gray. Oh, not that bad. Okay. I don't know what I'm still gray. Cool. So on top, I get my 6 minus 16, which ends up giving me x minus 10. And then I have x minus 10 times square root of x plus 6 plus 4. Well, my x minus 10 is a group by itself. It's being multiplied by 1. So I can cancel both top and bottom because there is a factor of each. So then I'm left with 1 over the square root of x plus 6 plus 4. Now, I know it looks terrible on I just wrote that, so I'm going to fix it. That plus 4 is not under that square root, so I don't want to make it assume. I don't want you to assume it is, because it's not. The only number under that square root is that 6. Okay, so we've rationalized that numerator, so we'll plug in the value. So we were looking for when x was 10. So 1 over the square root of 10 plus 6 plus 4. 10 plus 6 gives me 16. The square root of 16 is 4. So I get 1 over 4 plus 4, which is 1 over 8. Alright, that's all I got for you today. But I do want to make sure we understand that, if I go back a couple, when we started like we did yesterday, we can go ahead and plug in that x value as long as that x value does not somehow make the problem not possible. Trig functions can be approached like regular ones. I can plug in that value and solve. If I am asked to find a limit of a number that would make my expression not possible, because we know when we plug in -3 here, we get 0 on the bottom. We can't divide by 0. My first step is that I'm going to try and factor. So take a look. Do I have an expression I can factor? If I can't factor, can I rationalize the numerator? That means, can I multiply by that conjugate? So change that sign in the middle. Multiply top and bottom. Notice when we multiply those, the top I only need to take the first times first, last times last, because we've set it up so that our middle, the terms will cancel out every single time. All right, see you tomorrow.